This is a remake of our Kepler's 62 series. This is 62F. It is a super Earth exoplanet orbiting within the habitable zone of the star Kepler 62, the outermost out of five such planets. Discovered on the star by NASA's Kepler Space Telescope, it is located about 982 light years from Earth in the constellation Lyra. 62F orbits Peristar at a distance of 0.718 AUs, 66,700,000 miles from its host star, with an orbital period of around 267 days, and has a radius of around 1.41 times that of Earth. It is one of the more promising candidates for potential habitability, as its parent star is a relatively quiet star and it has a vast mass than the Sun. Through it, it can live up to a span of about 30 billion years or so. Based on its size, Kepler 62F is likely a terrestrial or ocean-covered planet. However, key components of the exoplanet still need to be assessed to determine habitability, such as its atmosphere. If one exists, it lies within the outer part of its host star's habitable zone, while E was in the inner part. Um, the discovery of the exoplanet, along with 62E, was announced in April 2013 by NASA as part of the Kepler Space Telescope data release. The exoplanet was found by using the Tresor method, in which the dimming effect that the planet causes as it crosses in front of its star's magic. According to scientists, it is a particular candidate to search for extraterrestrial life, and was shown as one of the targets to be studied by the search by extraterrestrial intelligence SETI. Mass radius and temperature. Kepler 62F is a super, placing it within the class of exoplanets with a radius and mass larger than Earth but smaller than that of the ice giants Neptune and Uranus. It has an equilibrium temperature of 108 K minus 65 C or minus 85 F, close to that of Mars temperature. I mean, which makes it marginal. I mean, but it's definitely bigger, but much bigger, more likely to have an active inner core, a magnetic field, and the mass to stay in the atmosphere, in my opinion. It has a radius of 1.46. Its radius is placing it below the radius of 1.6, where it would otherwise be a mini Neptune. I disagree with a relative composition with no solid surface. I think it's more like 2, but it depends on the solar winds and how things work. Due to its radius, it is likely a rocky planet. However, the mass isn't consistent yet. Constrained yet, I mean. Estimate place in upper limit of 35 Earth masses. The real mass is expected to be stiffly lower than this. The planetary habitable laboratory estimated mass of around 2.6 masses, assuming a rocky Earth-like composition. Its host star orbits star named 62, orbited by a total of 5 known planets. The star had a mass of 0.69 masses and a radius of 0.64 Earth's masses. I mean, our solar masses. It had a temperature of 4,525 K and is 7 billion years old. And compared to the Sun, it is 4.6 billion years old and had a temperature of 5778 K. Our somewhat metal poor with a velocity uh, of only 42% of our sun's. And orbit is 267.29 days. SMV major axis of 0.718 atomic units. Habitability, given the planet's age, 7 billion years, its and radius, a rocky composition with addition to a possibility some vertical amounts of water is considered possible. A modeling study indicates it is likely that a great majority of planets in its size range are completely covered by oceans. And if its density is the same as Earth, its mass would be 1.41 or 2.8 times that of Earth. The planet has a potential for hosting inbound, according to a study of tidal effects on potential habitable planets. The planet may be the only habitable zone candidate which would avoid disintegration by aeration from the host star at its current location. All through 62F may be an ocean-covered planet producing rock and water at the surface. It is the furthest out from its star, so without such a many amounts of carbon dioxide, it may be a planet covered entirely in ice. In order for 62F to stay in Earth-like climate, average temperature about 284 to 290 K, at least 5 bars of carbon dioxide would have to persist and be present in the planet's atmosphere. On 13th of May 2016, researchers at the University of California, Los Angeles, announced that they had found various scenarios that allow the exoplanet to be habitable. They tested several simulations based on Kepler 62F having an atmosphere and range of thickness from the same as Earth all the way up to 12 times thicker than our planet. Various concentrations of carbon dioxide in its atmosphere ranging from the same amount as in the Earth's. That's up to 2,500 times that level, and several different possible configurations for its orbit pattern. In June 2018, studies suggest that Kepler 62F may have season a climate similar to those of Earth. Wow, really cool. Um, I think it's pretty. I think it does have potential because it is the outermost planet of its star system, and the effects of tidal evolution from the inner planets in the host star and Kepler 62F are not likely to have had significant outcomes over a lifetime. Radioactivity is likely to have been unchanged, and through the planet might have an actual tilt anywhere from 14 to 30 degrees, and rotational period somewhat similar to Earth. This can further make the planet more sustainable for habitability, as it would be able to transfer heat to the night side instead of it being a planet with its surface being half water and half ice. I mean, with this orbit, it's actually possible. It is entirely locked. You could have actually a very Earth-like planet, but even so, it may actually be cooler than Earth. Or with its mass, it may actually have a thicker atmosphere, more carbon dioxide, and be able to be lower like Earth. I mean, I think both are possible. H-type stars like Kepler C2 can live for approximately 30 to 20 billion years, 2 to 4 times that of the current sun, our sun. The low stellar activity rate of orange dwarfs like Kepler 62 create a relatively benign radiation environment for planets orbiting their habitable zone, increasing their potential habitability. One review essay in 2015 included the Kepler 62F along with the exoplanets Kepler 186 and Kepler 442 were likely the best candidates for being potentially habitable planets. I mean, wow. I agree. I mean, yes, it's on the cooler side, but it's also a bigger planet, more likely to have a thicker atmosphere. I mean, yeah, we're not going to talk about its discovery too much. Uh, it's 290 light years away. It's too remote. It started too far from current time of the next generation plan telescopes to determine its mass, whether it has an atmosphere. The Hubble telescope. I wish they just replaced the Hubble telescope with another one, but they replaced it with these pieces of shit. I mean, let's be honest. Yeah. Well, let's look at this raging planet. This is right here. Here's an image of it. Uh, let's see what we got here. Yeah. Here is the planets compared to Earth in size. her is its habit zone. Her is F. Her is E. Um, Everything else is way too close to the star compared to our solar system. That's what we have on this planet.